to these things. Yes, bellows again. These things, I think, have been really relegated to protecting machinery, but their initial function was the movement of air. Of course, these days what we use is a centrifugal pump, and the big question is, which is more efficient? Well, that really depends on what you mean by efficiency, because if you're talking about the efficiency of air moved, then the bellows is more or less 100%. A centrifugal pump isn't. But if you're talking about mechanical efficiency, then centrifugal pumps suffer from air friction because they're moving so much more quickly. Bellows suffer from mechanical losses because of all of the folds. And so the jury's still out on that, really, whether it's more efficient or not. The real difference is the size. In order to move large volumes of air, bellows are large. In order to move large volumes of air, centrifugal fans are much more compact, and so they've won over. Because there's another important consideration, and that's the kind of airstream that you're producing. A bellows produces a kind of puffing airstream. I quite like it. It reminds me of a steam engine. A centrifugal fan will produce a constant airstream. Now, the force in the air isn't really an issue, it's just the settings on the fan or how much force you apply to the bellows. The two main differences are the type of airstream and the size. And I don't think that's really so much of an issue when it comes to developing and thinking about machines that you want to make yourself. And in fact, we made an air conditioning unit out of a set of bellows, and it was astounding how well it performed for the energy usage of it. I was quite amazed by that. So the bellows is a main component that I'm going to use. Now, I've done quite a few videos on making bellows, actually, including video 2023, which is how to go about hand making them with gaffer tape and strips of card. But I also did a video using the 3D printer in video 2353, where we looked at using a multimedia printer to print a bellows set from TPU and PLA. However you go about it, you make up the bellows bag, and of course it has two open ends. The ends need blocking off, and here I've just printed a square of PLA that's blanked. There'll be one end, and here there's a hole in it where the air can go in and out. So the major component that we're going to use to drive this thing is a couple of bellows. Of course, we need something to drive it with. And if you remember video 2327, this is the hypercycloid drive, and it's a pretty cool drive. If I turn that, what we can see is this rod going up and down. So of course, if I attach my bellows to there, that's going to pump the bellows. And in fact, of course, it's got two sides, and so we can put double bellows in it. Now, my plan is to duplicate this, so we have two side by side, here and here, with the bellows in between them being pumped consistently through a set of valves to create an airstream, a kind of puffing airstream. The puffing airstream we're going to put over this. This is video 2342, where I created the Blisk turbine, which was astounding, actually. So we're going to direct the air over the blades of that turbine using the hypercycloid engine to drive an airflow from the bellows that will create us electricity out. So I know that is tremendously Heath Robinson, or if you like American Ruth Goldberg, but I like that idea, and it's basically a little bit of fun to see if we can put some of the stuff that we've been doing together into one machine. Right, in order to do this, we need a little plinth like that, and that will be attached to the hypercycloid engine like that, and then we'll put the bellows in there like that, so it can be driven up and down with the hypercycloid. So first things first, let's add the extra bars, and here it is with the extra bars added. Two at the top, two at the bottom, going all the way through these slide guides here. Now if we compare that to the original, there's the modified. You can see 1 to 2. I've also changed the flywheel to a drive cog so we can actually drive it, and as we drive it, of course, what happens is they slide up and down like they should. You should also notice there's this lump on here, and that'll become more obvious later. Now, of course, that's no good by itself. What we need is two of them. So I've created two, and they'll go that way around. On here, on this one, you should notice there's the drive cog, and now there's a a wheel with a handle in it, so we can turn that handle to drive the whole thing backwards and forwards. And of course these two need to be held in place against each other, and for that we've got a base plate. So one goes on that side with the cog facing outwards, and the other goes on the other side, again with the wheel and cog facing outwards. So they're fixed like that. Okay, that's it on its base plate. Now I've also put these two crossbars here and here to hold the whole thing rigid, and you might notice I put the end caps on from the bellows. Now the other thing is this lump here should suddenly be clear. We've got two gears, one here, attaching to these large gears, and that's because we need to drive this from this centre. Without this joining gear, if I were to turn this handle, then what would happen is this side would get driven, but the near side to you would be a driving side, and what it would actually do is drive that cog round. Of course, we want to drive it, not it to drive the gear. If we drive the cog round, what will happen is it will twist like that, and if it twists, of course, it's going to lock. Now, if I take hold of my handle, what should happen is exactly what we expect. That's awesome, hey? So that should drive bellows one after the other. So the bellows are fixed onto the black plate like that, and then we have this big square block, and the job of this block is to take those glued in there like that and direct the air out of that hole on the top, and of course hold them in registration to the rest of the machine. Now there's a big square hole right there and a big square pin right there, and this goes onto the big square pin. So then I created two of these odd wishbone looking pipes that go in the two holes on the big block right there. And if you remember the valve that we created in video 2357, which is right there, we're going to use it as a check valve, and you need 4 of them. 2 of them go on that side so that the air can only enter. Then 2 of them go on that side so the air can only exit. Right, that's it all put together and finished. Now the air gets drawn in from behind and gets puffed out of these 2 exits here when I turn that handle, and if I put my tube close to it, yep, there's definitely the airflow coming out of there. Now, of course, all I really need to do is to take that airflow and point it at the vanes here of the blisk turbine, and we'll get ourselves a generator. Now, it might occur to you that that's a lot of trouble. I mean, I could have just put gears on it instead of doing something like this. So why would you bother making this Heath Robinson, Rube Goldberg monstrosity? Well, there's a few reasons, I think. I mean, one of them is you never know what you're going to discover when you're working through a problem. And when you're working through a problem, it forces you into creativity and coming up with solutions. The other, of course, is it's just good fun. And the third one is, although we're using this to drive a turbine, it could equally be an engine. I mean, we're drawing air in and puffing it out. If we draw the air in and force the bellows to move, then we can reverse this quite easily to make it an engine from a low power, a high volume air source, which I think in itself is pretty interesting. Anyway, I hope you enjoyed the video. Next stage, map this, I'm thinking somewhere like that, and we'll give it a go to see what we can generate from it. I obviously have to put the generation bits on the actual blisk turbine itself as well. Hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.